this is a session about virtual Kubernetes clusters, tips and tricks. When I came up with the title for this talk, I really wanted to get accepted, and so I thought I'd make it kind of clickbaity, so I put the tips and tricks thing in. And the thing is, here we are, it's the end of the day. I'm sure that people are starting to get tired. So I want to make it even more clickbaity than this and see if we can kind of pump you all up about virtual Kubernetes clusters. So how about 10 virtual cluster tips and tricks that will surprise you? Okay, I think we're getting there. I think it's a little more clickbaity, but I feel like we can top this still. 10 vCluster tricks that will make you a cloud-native rock star. Whoa. Okay, yeah, we're going to go with that. Hello, my name is Rich. I'm creator and host of a podcast you might have heard of called KubeCuddle, where I interview people from the Kubernetes community. Before I got into developer relations, I did ops for like 20-some years, and so I have seen some things.
And I'm Carl. I'm a dev here at Loft. I'm unreasonably upset that I didn't bring flip-flops because this weather is like the hottest summer day in Seattle. And I'm here to help out with some demo fun.
Awesome. So things we're going to cover today, we're going to talk about Kubernetes multi-tenancy challenges, what are virtual clusters, and some vCluster tips and tricks. So the why and what of virtual clusters. So Kubernetes multi-tenancy is really hard. There have been mainly two Kubernetes multi-tenancy models that people use, namespace-based isolation and cluster-based isolation. So let's talk about namespace first. That is where tenants are restricted to one or more namespaces using things like RBAC and network policies. Some of the pros of this approach. It cuts down on cluster sprawl, which is great. It's really hard to manage a whole bunch of clusters. There's less wasted resources probably because we're really packing the workloads in on our clusters. Some of the cons, users can't manage global objects like CRDs. Now, that's not something that you necessarily want them to be able to do in production, right? But if you're, doing dev environments or people are just wanting to spin up clusters for, POC kind of stuff, you want people to have a lot more control probably. And users may need multiple namespaces, like maybe they want to run services that actually are supposed to run in different namespaces and talk to each other. Then you end up getting like exceptions to your network policies and basically, these environments can get really complex when you've got a whole bunch of people running on a big shared cluster doing all kinds of different things. So cluster-based isolation is where everybody gets a cluster. Some of the pros of this, there's better isolation, right? Because we've just got one maybe team or person, operating the cluster. There's less complexity in each cluster. But some of the cons, it's difficult to manage all these clusters, and some organizations have tens of thousands of Kubernetes clusters. There's wasted resources because the flip side of the other one, we're not packing a bunch of workloads in, and the cost can be a problem too. One other thing I want to shout out really quick, I really love this talk by Holly Cummins that she gave at KubeCon a couple years ago. She used this phrase that I really love. She called them zombie clusters, which are clusters that are running and they've got workloads in them and nobody's using the workloads and maybe nobody even knows that the cluster exists anymore, right? And this is a problem because these things are using up resources, they're using up power, and that indirectly has an impact on the environment. So if this is something that interests you, I'd really recommend looking up that talk. So here you go. Which of these buttons are you going to push? So there's another option now. There's what's called virtual Kubernetes clusters. A virtual cluster runs inside of a host cluster, but it appears to the user as if it's a standalone dedicated cluster. And we're going to be talking today a lot about this thing called vCluster. And vCluster is an open source project that was launched in April of 2021. So almost the 2-year birthday, that's coming up. That's exciting. It's currently the most popular implementation of virtual clusters, and I think by quite a bit. There is at least one other implementation out there, but this is the one that really people are reaching for. It is a certified Kubernetes distribution, so it passes the CNCF conformance tests, and it is really fast and easy to use. So how does vCluster work? The virtual cluster runs in a namespace on a host cluster. And there's a vCluster pod that runs in there. It contains a Kubernetes API server and some other tools. And it saves its state in a database inside of that namespace. And that's SQLite by default, but you can point it at etcd or even Postgres. And the vCluster client that you use to interact with it is a really small Go binary. So let's take a look really quick at this architecture. So here's my host cluster. It's got the Kubernetes API server in it. It's got some other things. As an admin, I control the context of that host cluster, and I connect to its API server to do that. Now, I can make a namespace in there and have a vCluster pod inside of it, and that has some things in it too. So it's got the API server in it. It also has that data store that we talked about. It has a controller manager, and it has this thing called the vCluster syncer, and that's actually kind of the magic of vCluster, and we'll talk about that more. And so as a tenant using that virtual cluster, I'm going to connect to its API server, and I manage that context of the virtual cluster. And I can create namespaces inside the virtual cluster, and I can have deployments, I can have pods, all kinds of stuff inside of there. Now, one thing that you'll notice that's missing on that orange line for the virtual cluster is that there's not a scheduler. And that's where the syncer comes into play. So when I fire up a pod in the virtual cluster, the syncer tells the underlying cluster scheduler to schedule it. And that's where it runs. And there's this bidirectional communication because it's got to keep the state updated, right? So if the state changes, on either side, that gets synced up by the syncer. So that's the basics of how it works. And going to turn it over to Carl now, who's going to show you a little bit about this.
All right. Is that big enough text, we think, for everybody? All right, cool. So for this, wow, I'm very loud. For this demo here, we're just going to start with a really simple K3s cluster running in Docker here, spun up with K3D. And just to kind of start out here, we could just see it's 5-node cluster, nothing too exciting. And we can also check the pods, and we can see, okay, hey, nothing interesting going on. Just got our core DNS running. Cool. And now we can use the vCluster CLI or the vCluster CTL, whatever you want to call it, that Rich mentioned. So this is that tiny Go binary. That is how we deploy vCluster, or one of the ways we deploy vCluster. We're going to go ahead and tell it to create a vCluster. Pretty straightforward. We'll give it a name, my vCluster, nice and easy. We're giving it some YAML values file here, where we pass some other options. We'll talk a little bit more about those later. And we're just saying connect false because the default behavior when you spin up a vCluster is it wants to try to connect to that. And for demo purposes, I don't want to do that. So you wouldn't normally do that necessarily. So we can go ahead and just do this. Obviously, we're going to have some output here in a second. We can see vClusters going to spin things up. And now while we're waiting, we can use this vCluster CLI again to go ahead and list the vClusters that are running in this cluster that I'm connected to. And for a little bit, we're just going to see, hey, pod initializing. And we can kind of keep checking while I keep talking here. Well, maybe you can't see all of this at the bottom here, so you just have to believe me. But yeah, so we could see, hey, it's initializing. Probably on this one, we'll see that it's actually gone ahead and actually spun up and is in a ready state. This was real time. This is a real live demo that's happening right now. So the only kind of demo magic here is that I preceded the images into the nodes. That way it's, we're not waiting for downloads. But other than that, this was real time. So we created a vCluster. Very cool. One of the things that I had on that values file was saying, hey, in addition to the vCluster, spin up an ingress so I can connect to that vCluster. So we're just going to go ahead and check the ingress. Sure enough, it's up. It's got IPs. Okay, great. We can kind of keep going. Now we can use the vCluster connect command here. Tell it which vCluster we want to connect to. My vCluster, pretty straightforward. Again, update current false because I don't want it to update my kube context directly here. And I give it some URL here. This is just an Etsy host on my laptop so I can connect to it. Nice and easy, right? Cool. So you can see we've popped out a kube config here. We can just go ahead and cat that. If you've seen a kube config, you've seen a kube config. There's nothing really exciting here. The only really interesting stuff, and we kind of scrolled past it here, it went ahead and updated the server address to what I told it to. So that's useful, obviously. Now using the kube config environment variable, we can set that, and we can go ahead and get nodes on this vCluster. We can also get pods. Maybe, hopefully, there we go. And we can see, hey, sure enough, we're in this new thing. It's only got one node. We'll talk a little bit more about that in a little bit as well. And we've got core DNS. So for all intents and purposes, this is a brand new Kubernetes cluster spun up in like 30-ish seconds live here, and we're connecting to it. And it looks and feels like a real Kubernetes cluster because it is. Now we can do real Kubernetes things. So we're just going to do some really basic stuff here. We'll create an Nginx namespace, just picking on Nginx because it's easy. And then we're going to go ahead and create a deployment. Really, again, super basic stuff, just kind of for purposes of demo. Okay. All of this is looking and feeling like regular Kubernetes things because it is. And sure enough, we can go ahead and see if we check the pods that we do have our Nginx pods running. Nice and easy, right? Now, if we kind of back up a layer and go up to the host cluster or the parent cluster, and we look at the pods in this namespace, right? We can see the vCluster. So this is the vCluster thing that we deployed with vCluster CTL. It's just a simple stateful set or deployment depending on values you pass. Two containers in the pod. So that's the API server. So in this case, the default K3S API server. Then the other one is the syncer that Rich mentioned. And that's kind of where the magic happens. And then you can kind of see some other stuff here. So we can see Nginx. Well, those sure look an awful lot like those Nginx pods that we saw inside of the virtual cluster, because they are. So the vCluster basically synced those resources into the host cluster and did a little bit of namespace translation so that we can keep uniqueness, because we can run multiple vClusters in the same namespace. In all of those vClusters, we could have a namespace called Nginx, and in all of those namespaces called Nginx, we can have a pod called Nginx. So we need to be able to keep uniqueness even when something like this happens. So you can see we've got the name, a little separator, the namespace in the virtual cluster that it's running in, Nginx, and then the name of the virtual cluster that it runs in, right? And you can also see core DNS. So this is like ultra fast intro to vCluster, just the basics, and turn it back to Rich.
Yeah, and we're going to get into more demo stuff as we go. Yeah. Can we do questions at the end? Yeah. We've got a lot of material. I need to keep rolling. So just wanted to mention too that we're these demos, if there's something interesting that you see in them that you want to look at yourself later, we'll have a link to the GitHub repo that we'll show you all if you want to have a look at that stuff. So let's get now into the tips and tricks. There are 10 of them. Number one is distros. So the distro is the Kubernetes that's installed inside the virtual cluster. And as Carl mentioned, that's K3S by default. And that's what we started off with. So when we kind of built the proof of concept for this thing, it was just like, can we take K3S and make one of these virtual clusters? But as time went on, we had people approach us and they wanted other things. So somebody came to us and said, hey, can you all add K0S to the list? And we were like, yeah, that's a really cool idea. And then we were on a stream called Containers from the Couch that the AWS folks do, which is really great. And like a couple hours after the stream, we had a PR from Justin Garrison that added EKS to the list of the distros that you can use. So you can actually run the EKS Kubernetes, inside your virtual cluster if you want. And then we have what's called vanilla Kubernetes, which is just a standard Kubernetes distribution that has etcd in it. Tip number 2 is creating these virtual clusters. So there are 3 ways to do that. You can use the vCluster create command like you saw in the demo that Carl did. You can use the vCluster Helm chart. And if you noticed when Carl ran vCluster create, it actually ran a Helm command to spin up the virtual cluster. So you can do that with the CLI, but you can use Helm directly and just install that same Helm chart yourself. And we'll talk about that more. And then there now is, as of a couple months ago, a cluster API provider. So that's pretty cool. The Helm install, it's used by the vCluster create command. It's a really good option if you're doing some sort of GitOps workflow or you want some other kind of automation, as opposed to like interacting with the CLI. This is the repo for the GitHub for vCluster itself. There's a directory in here for the charts you'll see, and then there's a directory for each one of those distros that we talked about, right? And so this is the values.yaml file for the Helm chart for the K3s distro. And so this is kind of handy because you can look at this file and see what are the things that you can override. The flags in here correspond to the command line flags that the CLI has, so you can do the same kind of stuff that you can do with the CLI. And again, we're going to have links to all these repos and stuff at the end too, so you don't need to feel like you have to write this one down or anything. The Cluster API provider, if you are not familiar with Cluster API, it's used to provision Kubernetes clusters and manage their lifecycle. To use the provider, you need the Cluster CTL CLI that comes with Cluster API itself. And it creates the virtual clusters in the local cluster. And what I mean by that is the cluster that you are sending the cluster CTL commands to, that is where the virtual clusters will get created. And this is the repo for the Cluster API provider. And this is just a really brief example straight from the docs of how you would spin one of these up with just a little shell script. So it's got some Helm values in there. If you're using the values file, or you comment that out, and then it runs the cluster CTL generate command to actually spin up the virtual cluster. Tip number 3, exposing a vCluster. So we have one of these virtual clusters, and we want to be able to connect to it and interact with it. There are a few ways to do that. We can use port forwarding, and like Carl mentioned, the vCluster connect command uses that by default for like remote clusters. You can also use a node port, and that is actually used by default now for local clusters. So this got added just a few months ago, but if vCluster, if it detects that you're running like Minikube or Docker Desktop or something like that, it'll just set it up as a node port, so you don't even have to port forward to get to it. You can use a load balancer, and there's a _ expose flag for that. Or you can use an ingress like Carl did in his demo. Tip number 4, inception. So you can run a vCluster inside a vCluster, and you can go even farther than that. I did this talk originally at Cloud Native Rejects in Detroit, and there was another talk about vCluster where Mike Tugeron from Adobe was like nesting a whole bunch of these virtual clusters. I think he went like 18 deep or something crazy like that. So there's not necessarily a great use case for this. Like maybe you'll think of one, but like it's fun to do even if you don't have a use case for it. And back to Carl now, who's going to show you about this stuff.
All right. Cool. So once again, just to level set, this is our cluster, same as what we saw before, right? Looks normal. But what if we looked at the pods? Kind of scrolled a little wonky here, but hopefully you can see this all right. You can see this is not quite the same pods that we saw before. So what's going on here? Well, we created a vCluster called my vCluster in the previous demo. And sure enough, we can see my vCluster. We can see our Nginx pods that we saw before. But what's going on here? What are we looking at, right? Well, we saw in the previous one where we had the Nginx pods and Nginx and some hash, whatever, -x, the namespace that the pod was running in the vCluster, then the vCluster, right, when we looked at the host cluster. Well, actually, we lied to you. I lied to you. Rich didn't do any lying. I did all the lying, so sorry about this. And actually, for the previous demo, we were operating inside of vCluster 1. So again, like Rich said, there's probably not like a super great reasons for this. But we can absolutely nest vClusters. And when you do, this is actually kind of a cool way to illustrate. We can keep translating the names. And I know you guys were like, well, that's going to be a really long host name. Well, obviously, we have to concatenate this, and it'll get hashed. So we don't see the S, the rest of the my vCluster here just get hashed up and shortened. That way, we don't run into Kubernetes name length limitations. But yeah, so we can absolutely keep going. This is one of my favorite things too. Oh, sorry. And then this is just also looking from the perspective that we saw in the previous demo from inside of vCluster 1. And so in this case, we can see, hey, we're actually using the kube config for vCluster 1, which we hid from you in the last demo. Again, sorry. And we can go ahead and get the pods in this. Looks like what we saw before, right? And we can see again, here's our Nginx pod, here's our Nginx pod. They're just one more vCluster deep. All the pods are ultimately getting scheduled in the host cluster because that's where they all get scheduled. But we have these API servers just can continue to nest, right? So one of the really nice things, and actually like my personal use for vCluster, pretty much all the development that I do in a vCluster. And the really, really nice thing is I can go ahead and delete that vCluster, and everything that's in it, all of the pods and stuff that got created, are immediately cleaned up, or not immediately, right? They have to terminate, right? But now I've got a clean slate. So like my development like flow for building stuff for Loft is spin up a vCluster. I run Loft at home because, you know, whatever. And then in Loft, I create a vCluster, I connect to that vCluster, I do whatever it is that I do for the day. And oftentimes that means breaking things. So then I can go ahead and clean that up, and I'm left with, you know, no cruft in my home Kubernetes cluster, because we all want a cruftless home Kubernetes cluster, I'm sure. Anyway, we can see Nginx pods were already gone the first time that I looked at the pods here. And then we can see that the vCluster pod itself was terminating, and sure enough, that goes away. And then we can go back to our host cluster, and we're just left with, hey, that vCluster 1, and then the core DNS for that vCluster, right? So the cleanup part is, I think, often overlooked and probably my favorite part. So back to Rich.
Yeah, and those kube configs get generated automatically when you run the vCluster create command. So it gives you a kube config to connect to the virtual cluster. Tip number 5 is isolated mode. So this is another thing that got added in 2021, and that's actually sort of a theme of this talk. A lot of these things that we're talking about are features that got added last year that I think make the tool a lot more fun to use. So additionally, when we started off, we had use cases like dev environments and CI, CD, things like that in our heads. We were thinking a lot about ephemeral environments. And as time has gone on, people have started using this thing for lots of different things. There's now even people starting to use vCluster in other tools that they're making, you know, even in their products. CodeFresh not long ago, I think like 6 months ago, released a new feature where they now, if you go to them and you get a free Argo environment, that's actually using vCluster under the hood. And so as time went on, you know, people wonder about isolation, right? And so we made this isolated mode. You enable it with the flag, --isolate, and it creates some objects. It creates a pod security standard, a resource quota and limit range, and it creates a network policy if the CNI that you're using supports that. So this is, again, you know, just a way to get some extra isolation if you are in a situation where, you know, you don't want people, you know, in one virtual cluster to be able to talk to another one. And all of these things have kind of same default settings, but you can tweak them in that values.yaml file or with command line flags, whatever. Tip number 6, applying manifests and charts. This is actually maybe my favorite feature. So when you think about a cluster, you know, you provision a bare cluster. If you're using it for development, for instance, that bare cluster isn't really usable for you yet, right? There's going to be a lot more you're going to have to do. You're going to have to install things in it. You're going to have to do all kinds of stuff to get it to the point where you can really do your job. And so this feature is meant to sort of fill that gap. You can apply Kubernetes manifests or Helm charts automatically when the vCluster is created. And this is super, super handy. You specify the manifests and the charts that you want to use in that values.yaml file. And again, this is just, you know, normal Kubernetes YAML that you can use. You can use public Helm charts, or if you happen to have private charts, you can just point it at the tarball for the private chart. Tip number 7 is plugins. So this is a way to sort of extend vCluster. And the way that these work is these change the behavior of the syncer. So we talked about the syncer. That was the thing that tells the underlying cluster to schedule the pods. You can change the cluster, the behavior of the syncer to do all kinds of things. They're written in Go, and the plugins are very flexible. This is the vCluster SDK. So this is a repo for the SDK that you can use if you want to develop some of these plugins. And some of the reasons that you might do this would be to like, you know, some of the use cases that we've seen from people are like sharing resources inside a virtual cluster. Like there's something installed in the host cluster and they want it to be in the virtual clusters too without creating it in both places, or vice versa. And this is an example, a couple of example repos or examples that we have. If you you know, want to see, like we've got a cert manager plugin, and there's a contour plugin as well. If you want to write a plugin and you're looking for some examples. Likewise, if you write a plugin and would like to share it with the community, open up an issue, and we would be happy to add it to this. All right, back to Carl.
All right. Demo 3. So we're going to create yet another vCluster. Obviously, this is talking about vClusters. But this time, before we do so, we're going to look at the values file that we're going to pass. And we'll just use UIQ to just show the init section. So in this example, we're going to deploy some manifests. This is just really vanilla Kubernetes stuff. There's nothing crazy going on here. Like Rich mentioned, you could deploy Helm charts and stuff when a vCluster turns on as well. But for this demo, we've just got simple namespace, a secret, a silly deployment that's using this little image I made that just echoes an environment variable, and a service and an ingress to expose it. Again, this is all just Etsy host, so we can connect to it for the demo. So nothing too exciting there. Again, if you've done Kubernetes stuff, this is all pretty tame things. This time, however, when we create the vCluster, we'll go ahead and use Helm. Obviously personal preference how you deploy vClusters, but Helm is probably the most popular, I guess, I would imagine. In this case, we'll call it my vCluster 2. We're very imaginative with naming here, obviously. And then we've got some regular Helm flags you'd expect, create namespace, give it a namespace, values file that we just looked at, nice and easy, right? And obviously we can see, hey, Helm things are happening, yada, 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 pretty normal stuff. And we can go ahead and take a look at the pods that are coming up just to make sure things are working, of course. So again, no demo magic or anything. The only thing here is we've seeded the images. So this is all like real-time live vCluster magic. And we're just going to wait and kind of keep checking until this, all the pods are up and ready. Cool, they're up and ready. One more time, go team. There we go. And now we can look at the pods inside of the vCluster, or rather we can look from the host cluster perspective to make sure that that deployment that I mentioned in the init manifest is actually coming online. And sure enough, we've got our core DNS, that's fantastic. And then here's my little silly demo app, it's already running, fantastic. We can also check the service, and we've got a service, this is the demo service. The service names also get translated just like all the other names that you would see, so this should be familiar if you're used to vCluster things. And we can also check the ingress just to make sure that hopefully it gets an IP address soon. Sometimes it just takes a minute. I can interrupt my demo and make it look bad. That's cool. But yeah, so we're just going to wait for that. And then really quickly, if it wants to work. This is the risk with live demos, right? There we go. Cool. Then we can go ahead and test this app. So I mentioned before, this is just a super silly little, like totally ripped off from HashiCorp's little Echo HTTP thingamabobber. The only difference is I made it echo an environment variable instead of just some hard-coded thing or whatever, or some argument you pass to it. So race car, very imaginative. Palindromes are fun, I guess. So that's cool, but where are we seeing this? Where's this environment variable coming from, right? So I mentioned before that this image that I made just takes an environment variable and echoes it, right? So if we look at this, we'll go ahead and see that we're mounting a secret. That secret was in the init manifest that we saw. So it's called my secret. Fantastic. And then here's the image. We already know I lied. I didn't lie to you about this one. This is what it does. Very good. And again, we can go ahead and check that secret and see kind of what's going on here. One cool thing too, and this is like kind of secondary to everything, but vCluster connect, and then we could just dash and pass commands straight into the vCluster, so we don't necessarily have to set up an ingress or do anything crazy like that. But what's interesting is that the decoded contents of the secret that I mounted actually says Taco Cat. So that is not race car. For everybody playing along, I know they're very similar and easy to get confused. But so the question then becomes, what's going on? Where is this coming from? What gives? So we mentioned plugins, right? Here is yet another silly plugin that I wrote. It's called Prefer Parent Resources. You can probably guess where this is going based on the name. But basically, this is a plugin that says, hey, I would like, if these resources exist in the parent cluster, the host cluster, as opposed to the virtual cluster, I want to prefer those ones. So if they exist in both places, prefer the parent, right? And then just to confirm, hey, all we did was this values file, and we said, hey, run this plugin. Now, you might have noticed that there was 3 containers in this pod before when all the other ones had 2, so you might have been going like, hey, what's going on? We can look at the container names, and sure enough, vCluster pulled that image and put it as a plugin. Right? So that plugin is written using the vCluster SDK. It's a Go plugin. It's nothing really super complicated. And then it's obviously just packaged as a container to run and be ran by the vCluster chart there. So we can then go ahead and look at the host cluster, and we can see there is a secret, also called my secret, sensing a trend here, or a theme here. And we can decode it, and we can sure enough see that, hey, race car. So that's where it came from, right? So if I deleted this secret and obviously restarted that pod, the secret from the virtual cluster would get mounted, but this way it preferred that parent resource. So this is like a super trivial example or like silly example, but just gives you some idea of what the flexibility of plugins are and like how you can control what gets synced where and like all that kind of fun stuff. And then just lastly, because again, I wrote this thing, I know that I could grep the log and I can see, hey, it's mutating a pod. I found this one in the parent cluster or the host cluster. I want to prefer it over the one in the virtual cluster and move on with my life. All right, back to Rich.
Sweet. Thank you, Carl. All right, tip number 8 is pausing and resuming. And this is yet another new feature that we added. As we mentioned, it's really fast to create these virtual clusters and to delete them, but there might be times where you don't want everything to go away, right? You want to keep the cluster, but you want to get rid of the workloads. And that's what you do with pausing. And so there's a vCluster pause command, and there's a vCluster resume. And the pausing works by setting the number of replicas to 0. So this works for stateful sets, and vCluster itself is a stateful set, and it also works for the replica sets. And so what it does is it makes an annotation of the number of replicas that were there, and then it sets them to 0. And then when you resume, it sets it back to that previous value. So this just spins down all of the pods, and you can go about your day, and then you can bring them back up, but all of your other configuration and everything is still there, right? Everything else that you had configured in the virtual cluster. Tip number 9, we're almost done here. High availability. So this is, again, another one of those things. If you would ask me when we started off with vCluster, if we needed to think about high availability, I probably would have laughed. We just were thinking ephemeral clusters, dev environments, CI, all of that kind of stuff. And again, as time has gone on, people have just started using this for more kind of real things, and this is something that people were asking for. So we added in this HA feature. It creates multiple copies of the vCluster components, and it works with both the K3s distro, which is the default one, and also that vanilla Kubernetes one. It's actually kind of new that it works with K3s. We just added that recently. And you specify the settings for the different things that you're like, how many replicas you want in the values.yaml file. And here's just an example command line. So you literally are just running vCluster create and pointing it at that values file and specifying the distro. And we're going to actually, Carl's going to show you how that looks in just a minute. And number 10, this is actually brand new. This is from 0.14 of vCluster, which literally just shipped last week. So this is pretty exciting, generic CRD sync. We talked about that use case that a lot of people are writing plugins for, which is I've got a resource, whether it's an ingress or a secret or whatever, that I want to share from the host cluster to the virtual clusters or vice versa. This has been a lot of the reason why people have been writing plugins. But hey, what if you want to do this and you'd rather not write a big Go plugin? Really big news here. We have this new feature. It provides a way to enable the use of any asterisk controller operator in the host cluster inside a virtual cluster. The reason for the asterisk is just that this is very, very new. Oops, you define the mappings between the host virtual clusters just in a YAML file, which is really cool. And yeah, at this point, we can't promise it's going to work for everything. It's a brand new feature, but if you try it and you run into stumbling blocks, we'd love to hear about it. There was previously a vCluster plugin that you could use to do this. So if you happen to hear about that, this would be the preferred way instead of using the plugin now. And this is just an alpha that came out, again, last week. And back to Carl for our final demo.
You're almost done with me, I swear. All right, cool. So once again, we'll look at YAML. We all love to put YAML in the bucket. That's what we do with Kubernetes. So Rich mentioned HA. So here's a really simple HA values file, right? Some really obvious ones. Hey, enable HA. Yeah, that probably seems pretty reasonable. And then in this case, we also say, hey, let's also scale up the replicas for all of the things that we care about. And like any sane person would probably want to do that if you're enabling HA. There's some other stuff here that might be relevant here in a moment, but we'll get to that. So we can go ahead and look at some pods in this namespace demo. And obviously there's some stuff that jumps out. etcd 123 or 012, right? Pretty good. There's an API server, controller, the actual vCluster thing, and some core DNS. But what you might be noticing is there's like some other stuff, like maybe that demo that we just saw. So this is the last lie, or the last lie is now over. We have been in a vCluster the whole time. In fact, we have been in an HA vCluster the whole time. So the demo environment is actually K3S spun up with K3D, 5 nodes, straightforward, like vanilla, right? And then inside of that, we deployed an HA vCluster. One of the things you saw up here, maybe if you had quick eyes here, was that we synced all nodes. So by default, vCluster only syncs the nodes that have workloads running on them. So if you recall back to the first demo, and we said, hey, get pods, we saw core DNS, get nodes, and we saw one node. Well, that's because there was only one workload. We're running on only one node, so that's what vCluster showed us. And then in demo 2, we said, hey, get nodes. We saw all 5 nodes because we were lying to you and syncing all of the nodes into vCluster to our environment to make it look like a real cluster. I mean, it is a real Kubernetes cluster, right? So it's a white lie, right? It doesn't count. Anyway, we can see we've got all of the stuff running in. Here's our my vCluster 2 we just created in the previous one. Again, we saw the demo, and then my vCluster 1. And from the actual no more lies context that is the K3D environment, if we do vCluster list, we see only the one, the HA one, because that's the only one that's actually in the context. We would have to switch context to vCluster 1 to see the other vClusters that keep getting nested and so on and so forth. Yep, and then sure enough, if we go out and we look, we can see all of the things. It's kind of hard to see, but one of the things that you might have been wondering, I've been saying, hey, we're going to connect to this vCluster with an ingress, and you've probably seen, hey, Nginx in a couple of places, Nginx ingress. Well, where did that come from? We were looking at all the pods and all of the vClusters, and there was no ingress controller, so what gives? And actually, then Nginx ingress is running in the actual K3D cluster, and we've just synced it all the way down into 3 levels deep or whatever we did for that first demo, and we use that to expose our vCluster. So this is like one of the core benefits is we can have these cluster-wide things that are probably common, Nginx ingress being a really good example of that, and then we could create vClusters. And then the users or administrators of those vClusters, they don't have to install it because we can just say, hey, actually, you can use the one in our host cluster. And I think that is pretty cool. And I swear I'm done lying to you. So if there's questions, there will be no lied answers, I promise. But yeah, that's it for me.
All right. Thank you, Carl. You are the liar, but I guess I'm an accomplice.
Yeah, you are
or something. Yeah. All right. So just to wrap up here, some resources that we mentioned already, but here's a bunch of links. There's the biggest one by far is if you want to remember one thing, it's vcluster.com. So if you go to vcluster.com, that's where the docs are. That's where the link to the GitHub repo is. All of that kind of stuff. This is the GitHub repo for vCluster. We mentioned the SDK. That's the repo for it. And those example plugins that we showed you, the cluster API provider, the docs for that new generic CRD sync feature that we mentioned. And this is Carl's demo repo. If you would like to take a
You would like to lie to other people too. Spread the love.
And I wanted to mention we have a community Slack too, which is a really, really great place to ask questions and get help. The maintainers are in there. There's a bunch of users too. There's a vCluster channel itself. There is also now, as of a couple months ago, I think, a vCluster channel in the main Kubernetes Slack too. So if you're in the Kubernetes Slack, the community Slack, there is a vCluster channel in there. It is a lot newer, and there aren't as many people in there. Like the maintainers are in there and a few other people. So you're welcome to ask questions in there, but there are a lot of users in the community Slack, and so there's more people who can help you out there. I just wanted to say some quick thank yous to Oleg from our engineering team, who helped a lot with the kind of initial ideas for this talk. So thank you, Oleg. Also, the rest of the vCluster maintainers and contributors. I want to thank the organizers of the conference. I have helped organize conferences before, and it's a lot of work, so thank you very much for that. Also the AV folks and everyone else. And thank you for watching. And I think we maybe just have a time for a quick question or two.
We're here.
Okay.
Let's do it.
Yeah, of course.
So when you, from a virtual cluster, do kubectl get nodes, you will get a subset of the parent node.
Yeah, so
For-
default.
And for example, I use a plugin for kubectl shell node and specify the node name.
Okay.
So me, as a tenant, am I able to access the parent cluster node and have power on the other virtual clusters?
That's
Thanks.
a good question. That's a very good question that I don't know that I have the exact answer for. So by default, vCluster syncs only the nodes that there's workloads running on. So we saw that. We saw that you can also enable syncing all the nodes. There is obviously some lies there. There's more lies. This is getting bad trend here. There's some lies about the nodes. We can look here after. But I don't think that we show everything, obviously, because part of the idea is that, so there's fake nodes by default. You could disable that and show the real nodes. So I suspect the answer is it should be safe, as in they can't get to the nodes, but, right, yeah. Because like the node that we represent is some faked thing that we've synced into the, I don't want to say fake cluster. Yeah. So you're on, yep, totally. So I suspect, we could confirm, but I suspect that they shouldn't be able to do anything sinister. We'll just lie to everyone. Just keep the lies going,
Hey, so first, congrats on that tool. Looks great.
Thanks.
Honestly, I use Get-Ready for all the tests I'm doing locally. I'm not sure I would use vCluster because I don't need this inception. But I have a couple of questions. So first about efficiency. So, what are we giving?
Sure.
In terms of efficiency? I don't know if you want all my questions.
Yeah, let me
first.
answer because I'll forget.
Okay.
So from an efficiency perspective, the nodes get scheduled into the real cluster, right? There's a virtual cluster in that there's an API server that is running in a container in your real cluster, right? But the nodes actually get scheduled against the real scheduler in the real cluster. So from that overhead perspective, it's very little. Obviously, there could, in theory, be like some resource limitations. On the API server.
Yeah, I was just going to mention that. Yeah, so one thing that's kind of cool, and this was sort of unintended, but in a way, you kind of get API server federation by doing this, right? So if you've got a shared cluster and you've got a whole bunch of users on there sending API requests, they're only going to be hitting the API server of their own virtual cluster. And so, from that, there's an argument to be made that it's even friendlier resource-wise.
Second question I have is regarding permissions. So you have a tenant, inside you do whatever you want. But the question is, how are permissions managed from the outside? So first, can the nested cluster access the outside cluster resources, and how? And how do we manage those permissions,
Sure. Yeah. So from a resource perspective, if you sync resources, in, like an ingress, for example, then obviously you can create a resource in the virtual cluster that has like the Nginx ingress annotation or something, and then you can basically use the resource from the host cluster, if that makes sense. Pod-to-pod communication with like a default CNI that's not doing any kind of crazy security things still works. If you know the DNS name of some pod that's in the host cluster and you're in the vCluster, you could talk to it. By default, there's that isolated mode that Rich talked about, and you can control things with your CNI and do whatever you want from that perspective. But the default behavior is not isolated mode. So if you do know that, you can communicate. I'd say that like the thing to me about vCluster is it's more about API isolation than it is about like data plane isolation. We can help facilitate that with isolated mode, and obviously if your CNI supports that. But yeah, I don't know.
I had more in mind daemon set. So you expect the daemon set to be running locally, but you're not. It's not local anymore somehow.
Yeah. There is some host path mapper magic that's happened recently. I'm not the expert on this, but there's been some talk about daemon sets and how to make that work with virtual clusters. As far as I know off the top of my head, and don't hold me to this might be another lie, obviously. But the host path mapper can map hosts from nodes into the virtual cluster so you can access like a host resource. But that's not enabled by default, and that'd be something you'd like opt into. So if daemon sets from default might be a challenge, but we can check, and we could talk to Oleg, who is the vCluster man, and get you for sure answers.
Yeah, one of the things I mentioned too is like besides the isolated mode, if you are running a shared cluster and you've got these virtual clusters on it and you're concerned about the isolation thing, you still want to be doing the other stuff that you would do to secure a Kubernetes cluster, like especially admission control, on that underlying cluster. Yeah.
And sorry, last question. Did you use something specific for your script, for your demo?
Yeah, the script.
This is something you made, or this
No, I'm not that smart. There's a link at least in my linked repo. It's this script demo magic. I don't know if you know.
Yeah, it's a shell script.
Yeah.
It's on GitHub somewhere. It's just called demo magic, and it lets you do all kinds of stuff. Part of what we did is we actually were sending hidden commands to hide the fact that we were in these clusters.
Yeah. That and a little horrible bash. Don't judge me. I don't write bash very well. To like loop. So like if I was like, hey, vCluster list until it's ready. So bash and some dirty regex to make that work. But all plus demo magic.
All right. Well, thank you all for coming. This was really fun. Please do check out vCluster if it's something that you think can help you. And like I said, come on by the Slack and let us know if you have questions. Yeah. Thanks.
If there's more questions.